Hello again, AP Chemistry. Welcome to your summer homework, Unit 1, Lesson 2, which is going to be a metric and scientific notation review. So let's talk about this metric system. The metric system is very confusing when it comes to science, especially with science students. It is very disturbing and upsetting because we as America are the only ones that are still using it for the most part. Our country is using very old system. We talk about fractions of an inch, that there's 12 inches in a foot, that there's 3 feet to a yard, that there's 5.5 yards to a rod, that there's 320 rods to a mile, and 43,560 square feet to an acre. None of that makes sense. We are the only ones. All of this red that is highlighted on the map of the world are the only ones that are using this system, so it's very disadvantageous for us. But we do use the metric system for a few things. We buy pop and liters, we buy memory cards and bytes, we run 10-kilometer races, and we swim in 25-meter pools. But why haven't we switched entirely to the metric system? Well, because we just haven't. So, our metric system is very useful though. When measuring a person, we would use a meter. If we were measuring an ant, would a meter still be feasible, or what should we use? If we were measuring the distance from your house to school, what would we use? So what we do is we add prefixes. Prefixes will allow for us to convert these base units into something that's more feasible for us to measure. So Table D in that reference packet that's in that About section of Google Classroom has all the basic metric units, their symbol, name, and what they stand for, what quantity they're using for measuring. And then in Table C, they have the list of the prefixes that you're going to need to memorize, what the factor is for the prefix name, and what the symbol is, so that you can identify these when you see these measurements over the course of the year in AP. So when we put on and we're converting from one unit to another using prefixes, if a unit is getting larger, say for example you're converting something from a meter to a kilometer, then that means that your number is actually going to get smaller. And the opposite is true if your unit is going to get smaller. So if you're going from a meter to a centimeter, when you do your conversion right, your number is going to have to get larger. What about temperature conversions? Temperature is another thing that we're going to use a lot. Students ask me all the time, Miss Chris, why don't we use Fahrenheit? We don't use Fahrenheit because that's not a metric unit for temperature. We will use Celsius or Kelvin a lot of the times, mostly Kelvin in chemistry because we need to talk about absolute temperatures. So here is on the right is a picture that shows the comparison between the Fahrenheit, Celsius, and Kelvin temperature scales. Shows you where water boils, shows you where water freezes, and that absolute zero is going to be 0 Kelvin. The degree of Celsius is equal to the degree of Kelvin, therefore we only just apply for negative values. Zeros in Kelvin is the lowest amount of temperature that you can go. You can't have negative Kelvin. You can have negative degrees in Fahrenheit and in Celsius though. So we're going to use the following formula to convert. So Kelvin is equal to the number of degrees Celsius plus 273.15 K. And degrees Celsius is going to be equal to the number of Kelvin minus 273.5. What about scientific notation? Scientific notation has a specific format, and the format is m times 10 to the power of n, where m is going to be a number, a natural number between 1 and 10, and n is going to be the number of decimal spaces that you move to make m. So there are rules for coming up with scientific notation. First, you're going to find the decimal point. If it's not written, remember it's at the end of the number. Number 2, you're going to move that decimal point to make a number between 1 and 10. You can either move that decimal point to the left of the number, or you can move that decimal point to the right of the number, depending on whether the number is a big number or a small number. Then you're going to place the number of spaces you move the decimal point in the end spot. So if you moved the decimal point 3 places, then you're going to put a 3 there. Now that exponent's going to have to be either positive or negative. If your original number was above 1, it was a big number, then your exponent's going to be positive. If the number was a smaller number than 1, then your exponent is going to be negative. These are very important rules when determining scientific notation. You need to remember how to convert numbers to scientific notation because we are going to be dealing with quantities that are very large and very small. Scientific notation is going to be huge when we are dealing with mental math. So when you're multiplying and dividing, you have to remember that multiplying and or divide the base numbers first. Then you are going to add your exponents when you're multiplying. When you're dividing, you're going to subtract your exponents. For addition and subtraction, it's going to be a little different. The exponents must be the same in order for you to add or subtract them. So the first thing you need to do is to change your numbers to make this possible, to make sure that those exponents are the same. Then you're going to either add or subtract the base numbers, and you're not going to change that exponent. That exponent is going to have to stay the same. Remember, if the decimal move makes the base number smaller, the exponent should increase.